This lesson is on solving quadratic equations by graphing. A quadratic equation is something of the form ax squared plus bx plus c, a quadratic function, is equal to 0. To solve this by graphing, we call that quadratic function a function of some variable x. We then proceed to graph the function, and the zeros are just whenever the y value is 0. There could also be the case where you draw your quadratic and it never touches 0. In this case, we say it has no real roots. We say this because, as will be learned later, there can be imaginary or complex roots. But for now, if you draw your quadratic function and it doesn't meet the x-axis, it doesn't have any values when y is equal to 0, then there are definitely no real roots. Let's try some examples. So here I have some equation, and it has a quadratic function in there. So let's try graphing the quadratic function. So first, let's find the vertex. The vertex has the x value of negative b over 2a, which is negative 4 over 2 times negative 1. And that's just 2. Now when I evaluate this function at 2, I get negative 2 squared plus 4 times 2 minus 4. And this is just negative 4 plus 8 minus 4, which is 0. Now let's try graphing it. So I know it has a vertex when x is 2 and y is 0. So there's my vertex. And because a is negative 1 here, I know the parabola opens down, or that this vertex represents a maximum. So here I can kind of draw what I imagine it might look like, or I could try drawing it a little better. And notice that this only hits the x-axis when y is equal to 0 at this point that we've already found. When x is 2, y is equal to 0. That means we have our solution that x is equal to 2, allows the equation to be satisfied. So here I have problem number 2, x squared plus x plus 2 is equal to 0. I start by finding the vertex. X is negative b over 2a, which is negative 1 over 2 times 1. And now if I evaluate the function at negative 1/2, that's negative 1/2 squared minus 1/2 plus 2, which is 1/4 minus 1/2 plus 2, which is 1/4 minus 2/4 plus 8/4. So my y value at the vertex is 7/4. Now let's try graphing it. So I know my x-coordinate is negative 1/2, and 7/4 is about 2, it's a little less. So my vertex is going to be around here. Now note that my a value is 1, which is positive. And if that's positive, that makes my vertex a minimum. So my parabola opens up like that. And I know for sure this does not touch the x-axis, so there is no real solution. Now we have another quadratic equation, and we're going to talk about a special trick this time. So first, let's find the vertex. So my x-coordinate, negative b over 2a, is 2, and my y-coordinate is 3. So that's my vertex. So I know this opens downwards, and this represents a maximum because my a value is negative, so I can draw my parabola downward. But here's the question. How exactly is it? How angled is it? How narrow is it? How can I get a good estimate of what my solution is? What's special here to use is the axis of symmetry. So the axis of symmetry is at x equals -2, or not -2, +2. So this is my axis of symmetry. With my axis of symmetry, I know that however far one parabola goes, or one half goes, it's the same as the other half. These distances are the same. It's symmetrical, so those red lines should have the same length. What that means is that if I pick 2 points on here, then their average should give me a point on this line of symmetry, or axis of symmetry. So in the case where I want to find the zeros down here, I know their average has to be on this line of symmetry. So let's say I have this multiple choice question. It knows it's not easy for me to get my answer, so it gives me an interval. I have a 0 somewhere between 0 and 1 and between 2 and 3. Is that correct? Or maybe between 1 and 2 and 3 and 4. So let's try using the principle we just learned to find out. So if my number is between 0 and 1, that's going to be maybe, let's say, like a half-ish. And between 2 and 3, that's like 2.5. So let's say 2.5. If it's between 1 and 2, it'll probably be about like 1.5. 3 and 4, let's say like 3.5. 0 and 1 is 0.5. 3 and 4, again, 3.5. So essentially, these questions are saying my number is, for like answer A, my number should be about a half and about 2.5. It should be around there. Well, let's see how right that could be. If one of my numbers was a half and the other one was 2.5, remember, they should average to my axis of symmetry. They should average to 2. So is their average 2? In this case, it's not. Their average is 1.5. Now let's look at B. The average between 1.5 and 3.5 is their sum divided by 2, which is 5/2, or 2.5. Again, this is also kind of far off, so let's check for C. The average between 0.5 and 3.5 is their sum divided by 2, which is 4/2, which is 2. So it's 2. C seems like the best answer to me, so I'm going to go for that one.